Hello guys, welcome back to another video. And today I'll be participating in Biweekly contest 101. And I'll try to explain the thought process as I solve problems. Let's hope that the website do not crash this time. Oh no, what's this? Okay, it's fine. Don't do everything. Okay, so we have to find a number that contains at least one digit from both the arrays. Okay, let's do this. So we'll take the minimum of both of them from both the array. This should be min1. This should be min1 as well. Now, okay, there's a twist. If there is a number which is common to both of them, we'll actually return it. Let's short them as well. What am I doing? Now, if we found a number that is common in both the array, we can directly return it. Otherwise, return the minimum of 1 into 10. That's min2, or min2 into 10. That's min1. Let's check this. 15 and 3 so far so good. Is there any problem? It cannot have 0, so it's not a problem. I think it should work. Cool. Find the substring with maximum cost. You're given a string s, a string chars of distinct character, and an integer else of the same length as character. So there are different characters in string, and we have an array val. The cost of the substring is the sum of values of each character in the substring. The cost of an empty string is considered 0. The value of the character is defined in the following way. If the character is in the string chars, then its value is its corresponding position in the alphabet. Okay. Otherwise, assuming I is the index where character occurs in the string, then its value is values of I. Okay, return the maximum cost among all substrings of S. What is the n? It can be a lot of numbers. Maximum cost. Okay, so we have to find a substring from S, and if the characters of that substring belong to this chars, we have to pick the value from this array. Otherwise, we'll have to pick value in this manner. If it's the first character, it's A. If it's the second character, then it's going to be B in the reverse order. Like for B, it's 2, for A, it's 1, for Z, it's 26. Okay, you have to find a substring. Is this cadence? Looks like it's cadence. It could be cadence. Still think because if it's positive, we will definitely want to consider it. If it's negative, we don't want to consider it anymore. So I think it's somewhat similar to cadence. Let's have a map first. We're basically mapping the characters of chars with the values of vals. And now we'll map rest of the values. Now we have all the characters inside the map. Now we'll just do cadence. We have the maxi. Let's take temp, which is initially 0. Temp is map of as of I. If it's less than 0, temp will become 0. Yes, but there's an issue if all the values are negative, then what? Yeah, if all the values are negative, we can put something like this. Y0. So we are at A, which is equal to 1. It looks good to me. It should indeed be equal to 2. Okay, let's Okay, so we can have an empty substring as well. So it will be 0, 2 and 0. So it's basically contains. Will it overflow? I don't think so. Let's try this. Cool. Well, that was a nice question on cadence, to be honest. Make case of array sums equal. Okay. You're given a zero indexed integer array ARR and an integer k. The array ARR is circular. In other words, the first element of the array is the next element of the last element, and vice versa. You can do the following operation a number of times. Pick any element from array and increase or decrease it by 1. I think this return the minimum number of operations is that the sum of each subarray of length k is equal. Oh my god. This looks like a very heavy task. Been doing graphs recently. The graph has more summation than this one. Pick any element from array and increase or decrease it by 1. Return the minimum number of operations such that the sum of each subarray of length k is equal. When can we be sure that each subarray of length k will be equal? It says subarray. If they're the same elements being repeated after, no, that, yeah, actually no, but if k is big then all the numbers have to be equal. Let's read this question. There is a bidirectional graph with vertices for each vertex labeled from 0 to n minus 1. The edges in the graph are represented by given two integer array edges. ठीक है. Denote. ठीक है. Every pair of vertices is connected by at most one edge. Every pair. What do you mean? For this graph, 3 and 5 are not connected, and no vertex has an edge to itself. Okay, so there are no cycles, no self cycles. What do you mean every pair of vertex is connected by at most one edge? What do you mean by that? Return the length of the shortest cycle in the graph. If no cycle exists, you return minus on a cycle is a path that starts and ends at the same node. So let's forget about that. So basically we'll have to find the shortest cycle. Oh, it's not every pair of vertex, it's every vertex pair. This looks like an easy problem than the previous one for sure. Bidirectional means it's undirected. It looks like an easy problem. And it's not so big as well. So I'm just forming adjacency list. Um, but it looks too easy, to be honest. This problem looks too easy. Position. Um, I will do DFS. I will pass. Reason celeste will pass. Visited array. And that's all what we need.